Welcome to the Ball Drop Homework Introduction. This is an introduction to the homework that has been assigned about a ball dropping. Now, what I have here already drawn is the ball at its maximum height, right here. And that's where it is initially. And we let go and the ball falls. And we know that it accelerates. It picks up speed as it falls to the ground. And at this time, T2, this is the instant the ball hits the ground. Okay, let's examine what the acceleration and the velocity is doing at each of these times. So initially, we let go of the ball. The initial velocity is just equal to 0. And what do we know about the acceleration? Well, the acceleration is straight down. And we'll call that acceleration A1. Okay, now we do know something about the acceleration, and that is that A1 is equal to negative 9.81 meters per second squared. That's the acceleration due to gravity. It's negative because it's in the negative y direction. Okay, at our next time at T1, what changes? Well, our ball has picked up velocity. So now the ball has a non-zero velocity. We can draw that in blue. So this is our velocity. I'll call V1. And we know V1 is going to be a number less than 0. This is because the object is falling downwards. Its velocity is in the negative y direction. And we also know that the acceleration is downwards too. In fact, it's the same acceleration we had at the previous time. So this is our acceleration, A1. It hasn't changed because the acceleration due to gravity remains constant near the surface of the Earth. Okay, now the next time we have this is the instant the ball hits the ground. So at the instant the ball hits the ground, it has a velocity again which is downwards, and it's going to be larger than it was at T1. So this is our new velocity. I'll call V2. And we also have acceleration. Acceleration is still downwards, and it's still equal to A1. Okay, we know something about V2. V2 is also less than 0 because it's going in the negative y direction. So this is sort of qualitatively what's going on with this ball as it falls. Now, what happens when it hits the ground? Well, I've drawn that situation here. So if you look at the next time, so we'll call this T3, the ball starts to compress. So it's still, you can think of it as still moving down. It has some velocity as it's getting shorter, which is downwards, but it's not as large as it was the moment it hit the ground. So it's slowing down. So we can call that velocity V3. Now, since it's slowing down, there must be an acceleration. And the direction of the acceleration is upwards. So we can draw that acceleration like that, and we'll call that acceleration A2. Actually, let's call it A3. And what do we know about that acceleration? Well, the only thing we know is that A3 has to be positive, and it's upwards. It's positive because the acceleration is in the positive y direction, but remember the velocity is in the negative y direction. Okay, at our next time, at T4, the ball has finished compressing, and it comes to a stop. So at this time, we have v4 equals 0. But we still have an acceleration, which is upwards. It's still that acceleration, a3. And here we're going to assume that as this ball is being compressed and stretches out again, that the acceleration remains constant. So our acceleration is a3 once again. Okay, after it's compressed all the way, it stretches out again. So now, if we were to draw the velocity is upwards, just like that. This time, by the way, is t5, and our velocity is v5, and we know something about that velocity. That velocity is positive. It's in the positive y direction. And our acceleration, as this ball is stretching out again, is still upwards. So we can draw that. That's our a3 from before. Oops. a3. Okay, so that's what's happening when the ball is in contact with the ground, or at least as it's compressing and expanding. And what happens after that? Well, we have the rest of the motion. So at t6, which is our next stage, the ball is just about to leave the ground. It is fully stretched out again, and it's moving upwards. So we can draw that velocity. It's going to be large and upwards. Okay, so that is our v6. It's positive, at least it's in the positive y direction. Now, what is the direction of the acceleration? Well, if it's the moment we leave the ground, the ball is no longer accelerating upwards. Its velocity is upwards, but its acceleration is now downwards, and that's going to be the acceleration due to gravity. There. And that's the same acceleration we had before, so we'll call that a1. Okay, now at our next time, t7, we still have this acceleration downwards, and it's our acceleration due to gravity. It's the same a1 we had previously, and our velocity is upwards. It's a little bit smaller than it was before. So there's our velocity. We'll call it v7, and again it's positive because it's in the positive y direction. Now, our last moment in time, well, over here it's t8, and at that moment we reach our maximum height again. So at this point, our velocity is 0, and our acceleration is downwards. And again, it's still the acceleration due to gravity, which was a1. And you can imagine what happens next. Basically, this pattern repeats itself. Keeping all of these steps in mind will be useful for the ball drop homework in your activity manual. I hope this was helpful.